All right, today we're going to take a look at section 7.4. We're looking at percents. So the word percent actually comes from the Latin word meaning per hundred, as in our cent, which is worth 1/100th of a dollar. So that is that N percent equals N over 100. The first three kind of examples I'm going to show you just talk about moving between different types of numbers. I'm never going to ask you specifically to use one of these forms or the other. Some are more convenient with certain numbers. And so I just want to make sure you've seen them and are aware of how they're used before we actually take a look at converting some concrete examples with some context. So the first method is to write a number as a fraction with the denominator 100. For example, 7.9 is the same thing as 790 hundredths. Right? Imagine like turning 7.9 like $7.90 into pennies. You'd have 790 pennies, right? So that's the 790 on top, 790 on top, and it's 100 telling you how much each of those coins would be worth, 1/100th. And this is the same as 790%, because percent means the value per 100. Okay, so this is one of those ideas. A second way of doing a method is using a proportion. So 7.9 over 1 is equal to some number n over the number 100. We would cross multiply, right? And we would get that n equals 790%. Neither of those are probably the one you're most familiar with. The third one is probably the one you're most familiar with. But I will say methods 1 and 2, especially method 2, work they're very friendly when you're converting fractions into percents. Maybe not so useful in terms of the number 7.9 as a decimal, or if you had a whole number or something like that. But in terms of fractions, they can be quite useful. We'll see an example of that on example 1b. The third one is the one we're most familiar with, and it's moving decimal places, right? So if you take the number 7.9 and you move the decimal 2 to the right, you end up with 790% from that perspective. So those are all three perfectly valid ways of converting a non-percent number into a percent. I am going to focus on the first two because they're less familiar to you, just so you can see how they work a little bit. But especially this method number 2, where it does it as a proportion, we're going to see that used a lot today. So our number's 42.6. For example 1, and we're asked to turn this into a percent. So if you think about writing 42.6 over the number 1, we're going to multiply it by 100 to write it over 100. So this is like method number 1, just so you can see it worked out. This will make this 4260, like 4,260 on top, over 100, which gives us the percentage as 4,260%. Now I know that's not sort of the numbers we generally see in percent form. We see much smaller numbers most of the time, but it is acceptable to have a value that is over 100%. Okay, so that happens. Maybe not 4,260 on a regular basis, but you can definitely have numbers that are over 100. A lot of our values are under that, because a lot of places we see percents used is in taxes or in like growth rate of maybe like a stock or something like that, or you'll see something grow. All of our prices are going up right now. I don't know if you've noticed it or not. If you haven't, just go to the grocery store. You're going to see it. Everything went up, and so they all went up by a percentage of some level, not necessarily the same percentage, but case in point, the dollar store, as in Dollar Tree, is no longer $1 for all their items. Did you know that? $1.25. So it went up 25% because everything that was $1 before is now $1.25. That's a 25% price increase. So, $1.25 store. There are a few things there that are still $1, by the way, like the candy that you can get for 88 cents at Walmart. Just so you know. All right. Part B. So I wanted to show you the example of the proportion, that method 2 one on part B, because it is a fraction. If you tried to use method 3, the first thing you'd need to do is you'd need to take your fraction and you need to turn it into a decimal. And then after you have a decimal, then you'd move your decimal place 2 places over. There's nothing wrong with that, but it's kind of a 2-step process. So proportions actually work really nicely for this. So setting this up as a proportion takes the fraction you're given, in this case 8/3, and you set it up equal to the proportion n/100. And you're going to cross multiply. So we're going to have 3n equals 800. And you'll see we do still have that division part in the problem. It's just occurring in a little bit different way. So you're going to grab a calculator, or you're going to divide it out by hand, depending on at what point your students were working with this type of a problem. And you're going to get 266 point either 6 repeating, because it will keep repeating after that, and then you do your percent. And I'm fine with you leaving it like that, but just so you know, if you looked in the back of the book, for example, it might write this down as 266 and, 2/3%. That is, the 0.6 repeating at the end might be represented as 2/3. Nope. I just want you to know that if you looked in the back and saw that as like the answer for the problem, that it's just an alternate form. So either of those forms are fine. There's nothing really beneficial about one over the other, but it's 266.6 repeating percent. A lot of times problems, or even just in like practice in life, will round whole percentages to a certain number of decimals, or they might represent this as 267% or 266.7%. We'll leave our answers exact when we are asked to, but if they do ask us to round, we could certainly do that. Okay? All right. So just like we have options of turning numbers into percent, we have some options of turning percents back into numbers. So the first one, turning a percent into a number, is to divide the number by 100, right? So I don't think I have any example written down on my paper, but I can make one up. No. So for example, if you had 15%, method 1 is to actually take 15 and divide it by 100, because that's what percent means. And then you could actually do the division, right? 15 divided by 100. And so forth, we'll say etc., and it would equal to 0.15. Okay, so you could actually divide something by 100. That's one way of doing it. Again, not the most common way of doing it. More commonly, we see method 2 used, which is that you're moving the decimal point 2 places to the left. So again, if I had that same 15%, your decimal point right now is understood to be after the 15 because you don't see it. And if you move it to the left 2, you end up with 0.15, and then there's no more percent symbol on because it's no longer a percent. Okay, so just like with example 1, in example 2, we're going to be converting. This time we're converting the following into decimals. So we're taking our percents and turning them into decimals. So this does have the 4.5%. It's almost like this one over here where I wrote the 266 and 2/3, right? I've got 4.5. It does have a very nice decimal form. So if you wanted to, you could change this very quickly to just be 4.5% and work with it from there. That would be acceptable. So I'm going to show you method 1 because that's the one that's least familiar to you probably. So you're taking the 4.5 and you're dividing it by 100. Again, you can use your calculator to do the division. You could do the division, out longhand. And when you do, you find that this is, I got that written wrong. Missed one. 0.045 as a decimal. I'll do part B, and method 2 form. So on B, we do have something that's over 100%. So I mentioned before that the Dollar Tree, everything that was $1 is now $1.25. That's an increase of 25%. What that actually means is that the price of the product is 125% of what it used to be. So it does go over 100. Yes, ma'am.
So sometimes in our homework we'll get it wrong if we don't show our division work. So for like stuff like this, do we need to do long division?
So when we were working with division in the earlier sections, I mentioned that in class. Hopefully I mentioned it in videos. I know I mentioned it the first day we did 7.1 is that I expect to see the division that we're doing. As we're working with it in proportions, we're going to get some ugly values. There's no need for you to show those out.
So starting with this assignment.
Yeah, with this assignment on those ugly values, that because we're going to get it's going to be like context related, right? Like there's actually going to be like some sort of a real life context to it, and those don't always work out very nicely. So yeah, when we see things happen in the stuff earlier on, I do expect to see the division. And if you're in the middle of the test and you're wanting to know, like, do I need to show it out? Just ask. I'm happy to remind you. Yes, you do here, or no, it's not necessary there. Yeah. Okay. Thank you for asking. So the number here is 125%. That's actually what the cost of the soda was that I bought yesterday at the dollar store, compared to what it was 2 weeks before when I bought it at the dollar store. Is 125% of what it was the weeks before. So if we're thinking about this from method 2's standpoint, the decimal right now is here, right? And we're moving it 2 to the left, which puts it in between the 1 and the 2. So this is now the number 1.25. All right, everybody good so far? Okay, all of that's kind of some background-y kind of things to what we're doing in the last part or the next part of this lesson. So the real meat of this section talks about percent applications. And this is what I was referencing at the very beginning of class before I started the video about my son having brought things home. So we're looking at stuff 7th grade or thereabouts, depending on curriculum. So it could be something that shows up in 6th grade, up to maybe 8th grade, because things fluctuate a little bit. But somewhere around 7th grade curriculum is where you see these listed in the kind of objectives that you find. There are 3 different types of percent applications. The first one is finding a percent of a number. The second one is finding a percent one number is of another number. And the third is finding a number when a percent of that number is known. Okay? So my son was really struggling with knowing how to and where to apply each one of these. So I'm going to give you an example, just like how do the sentences read of each of these types of ones, so we can kind of discuss the differences in the structure of the language. Because it's the structure of the language that we have to be able to identify and then be able to use and move forward onto which one we're in. So the first one would be something like this. This doesn't have context, but it gives you the idea of the structure. What is 15% of 32? Okay, so finding the percent of a specific number. We often do this when we're finding our tithe, right? 10% of something. You might do this when you're trying to decide how much to tip someone, finding 15 or 20% of the total bill, right? Those kinds of things. So this is finding a percentage of a specific value. The second one looks something like this. What percent of 47 is 12? Okay, that wasn't what I had to do. I was just trying to move my dot. It looked like it was on the is. Okay. So, right, you could ask, if I had 5 A's and I have 32 students, what is the percent of A's in the class, right? If I have my take-home salary of $2,000 a month and $492 is spent on my car payment, what percent is my car payment of my total salary, right? That's what kind of a problem you're looking at for these. And then the third one, finding a number when a percent of that number is known, something like this. So 13 is 45% of what number? So this time we know a part of the problem, the 13. We know the percentage that it represents, and we don't know the whole. Right? So if I tell you that 45% of my class got a passing grade, and there were 12 passing grades, I'd be able to figure out how many students I then had from that information. How many students are represented by that 45%? So as we're working through these problems, what we're going to be doing is we're going to be first identifying, I know that the order kind of looks a little bit different, but identifying, or at least somewhere in there, identifying which of the types of problems there are. You know, is this problem number 1? Is this a type of problem number 2? Or is this like problem number 3 here? Which of these example types am I actually dealing with, or forms? Okay, so let's take a look at, hopefully we can get through at least these 3 examples, and then that's a good stopping spot. So the question says, what is the sale price of a softball if the regular price is $6.80 and there is a 25% discount? So here's the thing that I want to show you that is super, super like the trend in mathematics education for this content right now. This will be set up as a proportion. Okay, so let me show you how that works. So we do a line, we do our equals, we do another line. One side, and I don't really care which side, I usually put mine on the right-hand side, is the percent side. And it's always out of 100%. Now, if they give us the percent, like they do in this problem, that's going to go on top. But slow up, don't just write it in just yet, because we're going to make an alteration to it. But that's where it's going to go, right? All the percent stuff's going to go on one side. The other side has to do with how the original price versus a sale price or a discount or whatever is comparing things. All right? So in this particular problem, it says there's a 25% discount, but it also tells you that the price is $6.80. They didn't tell you the discount is $6.80. Do you see that? So we have to decide somewhere along the way, and it can be at the beginning or it can be at the end, to sort of make amends about the fact that this price and this discount don't match. And on this one, it's far easier to recognize it at the beginning and to make amends for that. For example, because my discount's 25%, how much of the percent of the product's original price are we paying? Right. So write yourself a note here. 75% is what we pay. And we're going to use the 75% in our problem. That 75% correlates to the price that we're paying of $6.80. Right? No, I'm sorry, I read it wrong. My bad. That was our original price. I was reading it backwards. So sorry. That was my sale price. I read my problem wrong. Okay, sorry. The original price, $6.80. If they'd given us the sale price, that would have gone on top, and they could definitely have given us that information instead. So what we're trying to find then in this problem is the sale price, right? The price that we're actually going to pay. So that's the missing piece that's on top. So one of the benefits in this proportional setup is that there's always 4 locations, and you usually get 3 of them given to you with 1 unknown location. And in fact, usually 2 of them, well, the 100's always given because it's always 100, but usually one of the 2 pieces that you are given, you know exactly where to put it from the setup. Like, it's super obvious. So that part's nice, and it makes this a nice way to solve the problem. So we are going to cross multiply. So I have, in some order, either 100x on the left or on the right. And then if you take the 75 and you multiply it by $6.80, what do you get? 510. And then we'll divide by 100. So what is 510 divided by 100? $5.10. Now, if we had chosen to use the 25% at the beginning, we would have had to make sure at the end to do what, Braden? You're about to tell me, weren't you?
We would have minus the, or regular price minus the.
Right.
45.
Yeah, you would have had to take the original price and then subtract it from what you got, because that would have been your savings as opposed to your actual cost. So make sure you're actually answering the question that's given, right? How much did you save? How much did you spend? Those kind of questions can be kind of interchanged accidentally, frequently. All right, take a look back at the 3 forms. These were our 3 forms. Which type of problem is this? 1, 2, or 3? It is 1. Yeah, this is the type number 1. We're finding a percent of a number. What is a percentage of a number that you've been given? All right, next one, a ski area. Near and dear to my heart, it's where I'm headed in 2 weeks. Ski area. Ski area reports that 80% of its runs are open. If there are 60 runs open, how many runs are there at the ski area? So again, there's no question of how to set it up. We're setting it up like this. Okay? All the problems will be able to be done that way. And yes, I know that there's other ways to do them. That's okay. You can check it with your way. That'll be fine. But we're going to show it this way because this is what our curriculum is sort of pushing us towards. All right, so 100% is what we're comparing this to. So it tells us 80% are open, 60 runs are open. Where do the 60 and the 80 go? Awesome. So it said 80% are open, so 80 is the percent, so it goes on the side with the 100, right? Where's the 60 going to go? Is it? Okay.
Yeah, 60. There's more runs at close.
Yeah, so 60 are open, just like the 80% are open. So it's along the top as the comparison, 60 compared to the 80%. And what we don't know then, of course, is how many runs really exist at our resort. So we'll cross multiply. We have 80x equals 6,000. Oops, there we go. And if we divide by 80, what do we get? 75. 75 what? Runs, total runs. Yeah, there's going to be context. You need to have units in your answer, whatever that means for your particular problem. Our last one was dollars, so that's what we included. I didn't mention it, but I did. I did show it. 75 runs. Which type of problem is this? It's number 3. And this number 3, I don't know the whole, right? Yeah, it's number 3. All right, we will end with number 5 today. Mort bought his house in 2008 for $159,000. It was recently appraised for $195,000. What is the approximate percent of increase in the value of his house to the nearest percent? So we're looking at a proportion with 100 in it. I'm given 2 numbers, 195,000, 159,000. Where do they go?
The 159 goes on the top and then 195.
So that's what people tend to think, but be careful. Okay, so no, so Abby, this is what happened. This is exactly what happened yesterday with my son. He always wanted to put the smaller one on top of the larger one, and a lot of times that's how they show up, isn't it? Right, we had 60 out of 75 runs, right? So that's typically what we see happen, but they don't always work that way. The 100% price here was his original price, and it's gone up since then, as opposed to decreasing and going down, which is what we want for our property, by the way. You want that to happen. So there's 2 things you could do. You could set it up with the 159,000 down here and the 195,000 up here. Okay, so it can be top heavy. There's actually one other way. The unknown, of course, is the percent. There's one other way you could set this up. We'll solve it next time. Any idea of how else you could set this up?
Is it like 100 on the top?
So I don't want to move my 100. The 100 will still be here and the X here. What I could do is I could set it up so that the numerator is the value of the increase. We're trying to figure out how much the house increased in price, right? How much did my soda at the dollar store increase in price? Well, it didn't increase $1.25, it increased 25 cents, yeah? So the increase could go on the top here, and if you take 159,000, 195,000, you subtract them, you actually get that the value of the house is now worth $36,000 more than it was before. Okay? Now, if we set it up like this, when we find our answer, it's going to be the real answer. If we set it up like this, we have to manipulate it a little bit more at the very end to give the answer to the question that's asked. So in some sense, this is like the question with the, was it baseball or whatever that was on sale, right? If we notice it at the beginning and we count for it then our answer is simply the answer that comes out of the proportion. If we don't, we have to be more careful and look at it at the end. So we'll solve this one next time, but let's actually answer. What kind of problem is this, 1, 2, or 3? Yeah, it's 2. Problem number 2 is the one where we don't know the percentage, and that's what we have here. We do not know the percentage in this particular problem. So we'll finish this one next time and move on to the rest of the lesson.